Hello friends, this is Mike from Wright, and this is the explanations video for SAT 2's Math, No Calculator section, question number 7. Right, here they say, if, oh my god, if x to the a to the squared over x to the b squared equals x to the 16, and if x is greater than 1, and a plus b is 2, a plus b is 2, what is the value of a minus b? We're ultimately going to try to solve for a minus b. Now that seems horrible, but it's question number 7, so it can't be that horrible. There's got to be some trick to it. They're expecting you to be able to do this question pretty quickly. There's got to be some trick to it, and here, lo and behold, there will be. So I'm just going to take you through step by step, and there's going to be a couple steps where it's like, I didn't know you could do that, and like, well, now you know. You got to learn. All right, so step by step, here we go. So here, x to the a squared over x to the b squared equals 16. That's just me rewriting this right here. And the first step involves one of the exponent rules. And here, this is a radicals and rational exponents question. These questions test, among some other things, your knowledge of the fundamental exponent rules. Here, the exponent rule that we're going to use first is the rule where if you have something to the same base, if you have an x over and an x under the fraction, if x to the a and an x to the b, then that's going to simplify to x to the a minus b. If you have two bases that are the same, and they're one's to the power of one thing, one's to the power of the other thing, you can subtract these things. That's what division looks like. That's what fraction looks like in exponents. X to the a over x to the b equals x to the a minus b. Now that's what we're doing here. So here's x to the a here's x to the a squared. That's this thing. And that's over x to the b squared. That's this thing. These x's are the same. So we can say x squared minus b squared. That's going to be the same thing as this. Right, so x to the a squared minus b squared equals x to the 16. That's just us applying this exponent rule. OK, now what? Well, next we're going to use the principle of symmetry. And that is to say, here they're saying that x to the a squared minus b squared is the same as x to the 16th. And here the principle is that if x to the something is the same as x to the something, then those two somethings are going to be the same. That is to say, like if x to the a is the same as x squared, then a needs to be 2, because it sure as hell isn't going to be 3, because x squared is not the same thing as x to the 3. That's what this rule is saying here. If x to the something equals x to the something, then those two somethings need to be the same. That's what's going on here, right? X to the a squared minus b squared, that's x to the something. That's the same as x to the 16. Well, a squared minus b squared had better work out to be 16, because if it works out to be 15, then we're going to be saying that x to the 15 is the same as x to the 16. It's not. The only thing that's the same as x to the 16 is x to the 16. All right, so a squared minus b squared is 16. Right? These two exponents need to be the same. These two are the same. All right, now here's the tricky trick. It's a common trick on the SAT. It involves this common binomial structure called the difference of squares. Here's when you see a thing squared minus another thing squared, that's what should, your light should go off in your head. Oh my god, I bet this is a freaking difference of squares question. And that's what's going on here. Things that look like this. You could add a 9 here and a 49 here, and it'd be like, oh, these are two squared type things too. Square thing minus square thing. There's a difference like subtraction of squares. These are squares, squaredy things. These factor out to this. This is going to factor out to a plus b times a minus b. And that's because this, so this a times a, that's going to be the a squared, right? And the b times b is going to be the minus b squared, right? So this b times negative b is minus b squared. And the reason why it looks like this is because the outside and the inside sort of cancel. Here's negative b times a, that's a minus ba. Here's positive b times a, that's plus ba. Those two things cancel, so there's no middle term. It's a special thing that happens. If you're still confused by that, watch the video on difference of squares. I'll go through it. It's not that hard. It's just the kind of thing you need to be able to recognize in these types of questions and apply really quickly. And that's really the major trick that's going on here. When you see a squared minus b squared equals 16, you need to then realize that this is a difference of squares. This factors out to a plus b times a minus b. And then from there, the question sort of follows pretty simply. Here, a plus b times a minus b is 16. And this is where the extra information that they've given us comes in handy. Here, they've told us that a plus b is 2. Right? And we're looking for a minus b. So we have a minus b here. We have a plus b here. So we're going to substitute in 2 for a plus b, because they've told us that a plus b is 2. So a plus b is 2, so this is 2 times a minus b is 16. And then we need to get a minus b alone. So we're going to divide both sides by 2, and a minus b is 8. All right, that's it for this question. See you all in the next one.